So we have a point 613. We want to know the distance from that point to the plane 8x plus 3y plus 7z equals 16. Is that right? Okay. All right, so the setup here is we have some flat plane, and then we have a point. And when we're asked to find the distance from the point to the plane, what do you think that even means? Because you could interpret that different ways, so we should first decide on what that means. So do you have an idea about what that would mean?
Like how far the closest distance to the plane?
Yeah, that's exactly what they're asking for. They're asking if you find the point on the plane that's the closest to this point, then what's the distance between those 2 points? In other words, you should take a line perpendicular to this plane, orthogonal to this plane, and take the line straight up to this point. Okay? So once we have that we can think about how to do this. We do know what this direction is, because we know what the normal vector is. So what are the components of this vector? Okay, good. The coefficients of x, y, and z tell us this direction. It's 8, 3, 7. That doesn't tell us the distance, but we can pick some random point on this plane. So let's say I know a specific point on the plane. I can take the vector from here to here, and then I can project that onto the normal vector. I can find the component of this vector in the direction of it. So this is a complicated problem. I'm glad that you asked about this one. This is the game plan. Does everybody understand the game plan? Find a vector like this, project it onto n. That will give us the distance. So how do I get this point? How can I find a point on this plane?
So you assume one constant, one variable x, y, or z, and then plug it into the plane equation to find it.
Okay, good. Just plug in 2 numbers for 2 of the variables, and then see what you get for the other variable. For example, if I plug in 0 for y and z, then I get x equals 2.
And then so on questions like this, is it always going to be obvious which one to make a number and which ones to make 0?
No, it won't. I mean, it doesn't have to be obvious. You should just look at it and see what would be the most simple. So probably it's going to be the most simple to choose zeros for 2 of them. And in this case, if I paid enough attention, I probably made it to where you would get nice numbers for at least one of the variables. All right, and this is the 0.613, so we can calculate that vector. What are the components of that vector going to be now? 4, 1, 3, 4, 1. Good. So we took the components of 613, subtracted the 200 to get this vector. Now I want to project that onto n. I don't actually need the vector over here. I don't need the full projection. I just need the distance over here. So how can I get that? Wanting this distance. Well, if this is a vector, let's say we're actually going to get the vector. Let's call it P. How could I calculate P? You remember?
Magnitude of the cosines of the 4.3.
good? Cosine, let's say cosine theta. Okay. Okay, good. So if we can use the angle theta between the two vectors to get this. Do you remember how we used that to actually calculate this projection vector? If we don't know what the angle is? Because here we don't know what the angle is.
Dot one.
Yeah, good. We turn this into a dot product. So do you remember how we turn that into a dot product?
Isn't it,
Oh, I should. Go ahead.
the,
Sorry.
the dot product, wouldn't it be just, to isolate cosine theta, you dot product two vectors and divide by the product of the magnitudes of those vectors.
That's right. But here, so here, I wrote P. Really what I should have written was N. So remember what I'm trying to do. I'm trying to take this vector N and scale it a certain length. And the length that I want to scale it is, it's not even this. The length that I want to scale it by is this length. So remember we made a unit vector going in the direction of N, and then we scaled it out by this length. And this length was this hypotenuse times cosine theta. So let's call this vector V. And then I'm going to need a V cosine theta times N. That does give me P. So this number V times cosine theta, or length of V times cosine theta, is what we want. But do you remember what we did in order to get rid of this theta, since we don't know specifically what theta is? We did use the equation that you mentioned. How did we use it? Anybody?
Well, you have vectors V and N. So therefore, would it be the dot product of V and N divided by the magnitude of V and N?
It is, okay, so that's very close. Let's think about how to get there. We need the dot product up here, so I'm going to introduce the length of N. That means I need to also divide by the length of N. So now up here I have the dot product of N and V. But this, remember this needed to be a unit vector that we then scale by this length that we need. So we need to divide this also by the length of N. And now, up on top, we've got the dot product of N and V. And on bottom, we've got the length of N squared, which was also the dot product of N with N, times vector N. But the piece that we're wanting is this length of V times cosine theta. Oh, so instead of walking through this, I could have used what John was trying to get me to use. We could have solved it a little faster.
Yeah.
Thank you, John. I'm going to stop in a minute so that we can take a little break before we start the quiz. We know this is length of N times length of V times cosine theta. We know that the quantity that we want is length of V times cosine theta. So we just divide both sides by length of N. And now we'll calculate N dot V divided by the length of N, and that will give you the distance. It's the length of this P vector. If this happens to be negative, then you actually need to take the absolute value, because we're wanting the distance here. So the final answer would look like this.
so that is the length, that is the distance from a certain point from a plane.
That's the distance from this point to the plane.
But could it be any point, or just, because I noticed
Yeah,
that.
it could be any point, but any point changes V. So this V was determined by this point and the point on the plane. The point on the plane, of course, doesn't change, but this point will change V.